was just saying, because you said it was sp2 on the right. If it has a lone pair, it can't. I don't think it can be sp2.
Oh, wait, shit. Yeah, it's not. Oh, okay, yeah. You're right. The hybridization is something else. It's something with s's and p's and d orbitals because we're breaking the octet. Good call. We still do have a p orbital coming out of the board here, like that, which is forming the pi bond with the oxygen. That's the important part. But yes, good call. That's not sp2. That's SPD something. Power Rangers, SPD. Something like that. Because, yeah, these guys still have. Yeah, all of that. And this structure is then. I drew it as trigonoplanar, but I have no idea what structure you get, because, I don't know, you start hybridizing d orbitals and stuff goes wild. That makes sense? It's a nice little mechanism, but, like, it's a nice little, like, a third of a mechanism that your book decided to show you, and therefore, I will not test you over, because that doesn't count as a mechanism. Otherwise, there's no, if this counts as a mechanism, then I can't tell you mechanisms should be mostly problem solving and not memorization, because there's no problem solving to get this step done. You literally would have to memorize it unless you know, the book actually showed you and wanted you to know the steps of that, right? Don't quote me on those steps. I'm not 100% sure they're real. They're just what makes sense to an organic chemist. What I would assume is the case. I think even if it's not right, most organic chemists would be like, oh, that looks right to me. So we'd probably have to Google it if it's actually not. But basically, SOCl2 is going to turn a carboxylic acid into an acid chloride. And that's not a real mechanism, so I'm taking it off the thing. Alright, we're still good. We've got 3 minutes. Decarboxylation, and that might be basically it. Alright, so next, we can do decarboxylation. Decarboxylation is, did I just? I hate laptops. Okay. Decarboxylation is when we sort of kind of do the opposite of a Grignard reagent. I mean, not really, because we're not going to end up with a carbon anion, right? Like that just, there's no reason that we would make that. We have to work really hard to make that in the first place and get magnesium in here and, you know, do all sorts of stuff like that. So it's not exactly the same, but it's kind of similar in that basically if you heat it up, eventually it'll release CO2 gas. Now, if you heat up any carboxylic acid, is that going to happen? No, it's special carboxylic acid. So remember our alpha, beta, gamma, delta? If on the beta carbon, we've got another carbonyl, it can be any kind of carbonyl, they're going to show us, I'm pretty sure they're going to show us this twice, once with a ketone like this, and then they're going to be like, look, it's a whole new thing, but it's exactly the same thing with just an OH over here too now. But if you've got a beta carbonyl, or carbonyl beta to your carboxylic acid, if you heat that, eventually you're going to form, you're going to get rid of CO2, kick off CO2 gas. And they're like not highlighting this H because I guess, I mean, that already has 2 hydrogens. In the end, it's going to have 3, so I guess net, that guy doesn't end up. Okay, this
you have a carbonyl group on your beta carbon, what that
If you heat this up, if you've got
it just does it sooner?
no. This is the only time it happens. Sorry. You can, this guy, without this, you can heat all day long. You're not just gonna like, because if you heat vinegar, like you don't just heat vinegar and then all of a sudden you're forming a bunch of CO2 and it's not an acid anymore, right? Like that doesn't happen. So this isn't a thing for all carboxylic acids. This is just special carboxylic acids that beta to your carboxylic acid have a, another carbonyl group. Every time I bump those into each other, I start thinking that I've accidentally locked one of the wheels, and maybe it's been me all along who's been locking it. I mean, it has been me all along, I assume, but. All right, so, this is my markers. There we go. So this only starts, okay, I'm gonna draw the first step. Because the first step, I don't know, it's a step in quotes, nothing happens really. So we've got, and this doesn't have to live in this shape, right? So the first step is just sort of, there, that's in quotes, because it's, but we do a nice little swing things around. And we just rearrange it so it, not rearrange, sorry. I'm trying to, configuration? No, configuration can still be breaking a bond. We twist it. We twist it around. We literally just twist it around in space so that now that, and that. Because what does that look like? Nature loves them. Six-membered ring, right? I mean, it's not a six-membered ring, but like, you definitely can have some hydrogen bonding going on there. So, in reality, I mean, they say that this is a, well, they call this a transition state, but honestly, the transition state is really, it's going to be right in between. This isn't the transition state. The transition state is like, well, you can never draw a transition state, so I'll show you that. But, okay. Wait, that's fun. All right, let's do some arrows, because this is super fun. We have this little ring adjacent thing going on, and we go, hey, what if I went and, that's not already a bond, so we'll point right at the hydrogen. What if those electrons went there and these electrons went here? That could be super fun, right? Now, that's going to try and make a 5-membered ring, and we could bump these electrons down because that's just, I don't know, intuitively, like that's just what feels right deep in our hearts, right? But if we kick that over, then we've just formed CO2 gas, which is, you know, pretty stable. So it actually does that. And we get, let's see. Let me make sure I'm not, yeah. That and this. There we go. Now we've got this. And we've kicked off. Yes. All right. What does this look like? is this guy? This guy. Not anymore, right? Because that's not an oxygen. So this has two functional groups, yeah, enol, en and all. It's an alkene and an alcohol, yeah. So we have an enol, right? Oops, we formed an enol. I know exactly what we can do with that, because which one's more stable, a carbon-carbon double bond or a carbon-oxygen double bond? Carbon-oxygen is more stable, right? So we can do, just do it this way. Let's see. I mean, we can just do this. I don't know. I just sort of want to do like. No, that's not. I don't know what I'm doing. Here we go. No, we do. All right. I know. We can do stuff has electrons, and it's gonna go, hey, that's a nice hydrogen you got there. Can I have it? And it's like, yeah, sure. And then these go, hey, let's go form our thing. And this goes, wait, I need something. And it's like, hey, well, you gotta do this in a protonated solvent. You're gonna have to have some, see, you don't actually, yeah, I don't think you actually need to use, yeah, no. You don't actually need, like usually keto-enol tautomerization, we do like acid-base, we can do it in acid-base or base, right? But like, basically all we need is a protic solvent, right? Because even if we haven't actually drastically increased or decreased the pH, I mean, if we just have water, we actually have this in equilibrium, right? So there's a little bit of both of these around. So this guy happens anyway, and we just sort of have that. I can do it all in one step here, or we can just sort of, I don't know, have nothing deprotonate that, so we get a charge structure, and then we can reform and steal the hydrogen, but I don't know. Basically, it's this. I just don't actually want to write this like it's going up here, because that's like a 4-member ring transition state. That's not real, right? So basically it ends up taking a hydrogen, but it just doesn't take it directly from there. And then we get, yeah, that. Because that was a CH2. Here, let me just do H. And now we've got 3 H's. Now we've got this. The transition state that they're talking about is, I mean, anytime we've got a transition state, so you guys remember reaction coordinate diagrams? Energy is over here, and you've got reactants and products, and this, I guess, exothermic reaction, and we've got this, right? And this is activation energy. This at the very top is your transition state. So transition states are like never going to be able to never going to be able to be drawn with like bonds and organic chemistry like making sense. They're always right in between. Like they're literally the point right in between one bond breaking and the other bond forming at the highest energy possible point. So yes, we sort of have our actual transition state is like this, and let's see. That guy's only half a bond. This guy is a bond and a half. This guy's a bond and a half. This is half a bond. The dots no longer mean hydrogen bonding, they mean half of a bond. And that's a bond and a half, right? Because every bond that's about to break is halfway between breaking. So, yeah, I just didn't like that they labeled this specifically as your transition state. I guess you could call this a transition state once our mechanism arrows are in there and you're a lot closer to being right, but yeah. Does that make sense? This, well, most of that, because I don't actually care, I'm just being specific so that later, when you learn about transition states, you don't accidentally remember this and get confused because I semi-lied to you and called that transition state. I'm just being technical, but like, yeah, good? So, if you take a beta carbonyl carboxylic acid and heat it up, then you're gonna spit out CO2 gas. All right. Yep, because this was that. Let's see. So they're showing you this. If you've got this whole molecule, and they just, I don't know, your exam question is like, here you go, here's a thing. We heated this up, what happened? We just heated it up, and that's all we did, what happened? I guess it would be more useful to look at this before it was color-coded. But we're trying to find a carboxylic acid group, right? So we find all three of our carboxylic acid groups, and then we count how far away the carbonyl group is from each of them. So this guy has a carbonyl alpha, just one away, right? That's not gonna do it. This guy has alpha, beta, gamma, or alpha, beta, gamma. Well, neither of those are gonna do anything. That's not useful to us. But this guy, alpha, beta, it's got a carbonyl 2 carbons away, so this is the only carboxyl group that is gonna decarboxylate. Yeah, decarboxylate. Yeah? Yeah. Hold on, we're just gonna unhide that. Because I could draw the same thing again, or we could just say, this is decarboxylation, and look, now it's not an aldehyde or a ketone anymore, it's a carboxylic acid group. Yeah. Still a carbonyl, but it's a carboxylic acid group. Well, I mean, now you get to choose which one you get rid of because they're both identical, right? So that's fun and exciting, but exactly the same thing. Literally exactly the same thing. It's just that this that used to be R is now an OH and just stays that way. Yeah? We good without drawing this one out? Because it's all the same? Yeah. So, I like this little ring, I don't know, ring scooching around thing. So, you should know this mechanism with that thing. All right, let's see. Oh, yep, that was it. Cool. We made it. So we go through and we've got like 4 minutes left. We can go through, we can do a problem solving thing, or we can do some of these like multiple choice questions, join in questions, or I can try to do a Fisher acidification in like 3 minutes. Raise your hand for, or we can just, this is 3 minutes. We can't do that much. I talk fast, but I don't talk efficiently, so there's no way gonna get through it to be useful. Yeah. So, ideally, I will have your quizzes on my desk when I go back to my office, depending on what time Nurul gets in. So, hopefully by my office hours after lab, you should be able to come pick up your quiz if you want. Probably. No promises, because, you know, I don't know yet, but that should be the case. That'll probably be the case. I will post the keys to quizzes 1 and 2, so that you can use those as study. I didn't post yesterday's slides. I forgot to yesterday, so I posted them this morning, and I'll post these full slides. And then I'll post the full chapter 17 slides, so you can just have all of that together. And yeah, happy Friday. We've got an exam Monday. Come hang out with me in office hours. Don't be late to lab. Put questions on the discussion board. Work together on studying and on homework and stuff. Good luck. You can do it. I believe in you.
This lab's gonna take absolutely forever.
Oh, this one.
It's gonna take so long.
When does lab
There you
end?
go.
1?
It's gonna be long.
It's gonna take
Okay,
forever.
usually it's like scheduled, so
It's
my office hours
scheduled
are
till
technically 1 and 2. But also, I'm going to office right now, so.
I just wanted to go if chemo turns out.
Oh, okay, yeah, well,
So come at like 1.
yeah, maybe come at like 1 if you want
Okay.
your quiz back, because I do have to go, you know, look through those and do stuff. But yeah, if you aren't taking lab, I have semi-unofficial-ish office hours touring. Why not?
We were just wondering if you come up with like a list for all the mechanisms. I mean,
Oh,
that
I posted that.
Oh, you did? Okay.
Yes, and I just
haven't got a
didn't.
chance to look.
I wasn't sure. So is it useful to like? I don't know. Like, I wasn't sure if I could. When I posted, like, when I
Yeah.
post a new file, it doesn't give me the option to just like notify students of this. When I post a new like assignment, it gives me that option, so I can
Yeah.
just do that without making a new announcement. But for a file, it doesn't have that. Is it useful to like make a new announcement whenever I post things that you guys are looking forward to? Because I can. I'm
If you
totally not
want.
against it. I just don't want to overload you guys with like, oh my god, there are like 50 billion announcements, and each one is like minor.
No, if you want to, you can, but it
Yeah.
doesn't.
Okay.
I just
It
haven't
wouldn't-
gone to
okay.
Or like,
It would not be negative.
Yeah.
or
Okay,
like
it would
if
be
you
neutral.
have like, maybe not for like one thing, but if you
Yeah.
post like 2 or 3.
Yeah.
And then
Okay.
like a
Yeah.
summary or something.
I was planning on finishing the quiz keys and doing an announcement after I did those. And yeah, no, I didn't do that last night.
No, it's
so I only
fine.
posted the one thing. But
Okay,
Or
that's
like,
awesome.